to the sheet titled hyperbola. जो भी बोला. Okay. So the first problem, a comprehension, a passage which is about an ellipse x square by 36 plus y square by 18 equal to 1. That's an ellipse given. And then we have a hyperbola. We have a hyperbola whose one asymptote is major axis of this ellipse. Whose one asymptote is the major axis. In this case, the major axis is the x-axis. Do you see that? The major axis is the x-axis. So one asymptote of the hyperbola is the major axis. The eccentricity of the given ellipse and hyperbola are reciprocals of each other. Now, what is the eccentricity of the ellipse? 1 minus 18 by 36, that is half, or E is 1 by root 2. Eccentricity of the ellipse is, say, E1, 1 by root 2, the eccentricity of the ellipse, right? So, the eccentricity of the hyperbola then would be root 2? Yes or no? And if the eccentricity of the hyperbola is root 2, what's the nature of this hyperbola? It's a rectangular hyperbola. This means that it's a rectangular hyperbola. Now, it's a rectangular hyperbola with one asymptote being the x-axis. Now, in a rectangular hyperbola, the asymptotes are perpendicular to each other, isn't it? In a rectangular hyperbola, the asymptotes are perpendicular to each other. That means if one asymptote is the x-axis, the other asymptote must be the y-axis. And the center of the hyperbola would be the intersection of these asymptotes, which is the origin of coordinates. Yes or no? So it's a rectangular hyperbola with the x and the y-axis being the respective asymptotes. Yes or no? Right? So we have a hyperbola with the x and the y-axis as the... Now, however, you know, the hyperbola could either be in the first and the third quadrant or the second and the fourth quadrant. There are two cases, right? Now, refer to more data. The ellipse and the hyperbola, they touch each other in the first and the third quadrant. That means the hyperbola must be located in the first and the third quadrant. That means this must be the hyperbola. Yes or no? The equation of the hyperbola with the x and the y-axis being the asymptotes must be what? Must be xy equal to c squared? Must be the equation of the hyperbola, yes or no? Right? Now, this curve, the ellipse, this curve, the rectangular hyperbola, they touch each other. That means their points of intersection must be coincident. Their points of intersection must be coincident, right? In order that they touch each other. That means if I solve equation 1 and 2, let me see what I get. On solving 1 and 2, that is, I'm seeking to find the points of intersection of the hyperbola with the ellipse, right? X square by 16. And this y, I replace by c squared by x. So c power 4 by x square. Equal to 1. Between 1 and 2 by eliminating y. This would give me the x coordinates of the intersection of the ellipse with the hyperbola. Now for tangency, what is required? The roots of this must be coincident roots. The roots of this must be coincident roots. Yes or no? Now this I could write as, oh, this is 36 by 36, right? This I could write as 1 by 36 x power 4 minus x square plus c power 4 by 18 equal to 0, which is a quadratic in x squared. Which is a quadratic in x squared. And for tangency, what is required? The discriminant of this quadratic must be equal to 0. Yes or no? The discriminant of this quadratic must be equal to 0. Clear? So, for tangency, discriminant equal to 0. Yeah, sorry, x square, multiplying by x square throughout. This is what I did. So, 1 minus 4c power 4 by 36 into 18. That must be equal to 0. 9 into 18, 9 squared into 2. So, c squared must be 9 root 2. Yes or no? C power 4 is 9 into 18. So, c squared must be 9 root 2. Yes or no? C squared must be 9 root 2. That means the hyperbola must be xy equal to 9 root 2. That's the equation of the rectangular hyperbola. Yes or no? So far so good? Right? Okay. Can I remove the clutter from here? Let me just write down that equation. X power 4 by 36, right? Minus x squared plus c power 4 by 18, right? Let me just retain it for the time being. That's the x coordinates of the intersection of the hyperbola with the ellipse, right? That's the equation, just mapping it back. Now, we want to be able to find the focus of the hyperbola. Let's say the focus in the first quadrant. Let's say the focus in the first quadrant, isn't it? It has a focus in the first quadrant, it has a focus in the third quadrant, right? The asymptotes being the x and the y axis. One of the branches, I seek to find the focus in the first quadrant, say, of this hyperbola. Now, if these are the asymptotes, then the axis of the hyperbola, the transverse and conjugate axis of the hyperbola, must be angle bisectors between the asymptotes. The angle bisectors between the asymptotes. The angle bisectors between the asymptotes must be the transverse and conjugate axis. Yes or no? Now, one of the angle bisectors between the x and the y axis is the line y equal to x. Yes or no? This is the line y equal to x, which is intersecting the hyperbola at a real point A, and therefore this must be the transverse axis, right? The transverse axis would intersect the hyperbola at real points, but the conjugate axis will intersect the hyperbola at imaginary points. And of course, the other axis, the conjugate axis, must be the line y equal to minus x. Y equal to minus x, the line perpendicular to this, passing through the center. Right? But I don't need that, so I don't bother too much about that. Clear? So y equal to x now. Can I find the coordinates of A? A is the vertex of the hyperbola, isn't it? Intersection of the transverse axis with the hyperbola will give me the vertex of, so A must be the vertex of the hyperbola. So its intersection with the line, intersection of xy equal to 9 root 2 with y equal to x would give me A and let's say another A prime in the third quadrant. Yes or no? The two vertices. So put y equal to x here. If you find the intersection of xy equal to 9 root 2 with y equal to x, then you get x squared equal to 9 root 2. Putting y equal to x, seeking the intersection of the hyperbola with the transverse axis, and in the first quadrant, the x coordinate of intersection, that means for A, x is positive. So for A, x turns out to be 3 into 2 to the power half, 2 to the power 1 by 4. That's the x coordinate of A. Yes or no? And since A lies on the line y equal to x, that's also the y coordinate of A. That means A has coordinates 3 into 2 to power 1 by 4. A has coordinates 3 into 2 to power 1 by 4, comma 3 into 2 to power 1 by 4. These are the coordinates of A. Yes or no? These are the coordinates of A. Right? Now, this is the focus. One of the foci, which lies on the transverse axis. Which lies on the transverse axis. Yes or no? I need to find the x and y coordinates of this focus. Very clearly, this angle is 45 degrees. Now, the eccentricity of the hyperbola is root 2. So, if this is small a, this length will be a root 2, isn't it? AE comma 0. If this is small a, if OA is small a, then this will be a root 2, isn't it? This will be a root 2 AE, right? This length is AE, so a root 2. That means if this length is root 2 times this length, then this must be root 2 times this, and this must be root 2 times this. Yes or no? Yes or no? That means the x and y coordinates of S would be respectively root 2 times this and root 2 times this. Yes or no? Root 2 times this means 3 into 2 to the power 1 by 4 into 2 to the power half, which means 3 into 2 to the power 3 by 4. That means S has coordinates 3 into 2 to the power 3 by 4 and y coordinate 3 into 2 to the power 3 by 4. This is one of the foci, right? Got me? The other focus would be in this quadrant, which would be negative of these numbers. Negative of these numbers, the other focus. All right? So far, so good. I hope all of you understand this. I just said this is AE. This is A. This E is root 2, so this is root 2 times this. So this would be root 2 times this. From similar triangles, this would be root 2 times this. Clear? And this is given to be 3 into 2 to the power 1 by 4, which is this. And root 2 times that would be this. Clear? Okay. Now, number of points in the xy plane from where perpendicular tangents can be drawn to the hyperbola. It's a rectangular hyperbola. It doesn't have a director circle, except that, you know, the director circle at best could be looked upon as a point circle, which is the center. Again, from where the asymptotes are drawn, you don't look upon asymptotes as tangents. Asymptotes are not tangents, so 0. 0. 0 is the answer, right? You don't look upon asymptotes as tangents. They are limiting cases of tangents. They are not tangents. So, you know, the x and the y axis, they are the only two so-called perpendicular tangents which are asymptotes, but they are not really tangents. They are not really tangents. So, no tangents could be drawn because it's a rectangular hyperbola, right? 0. The equation of the common tangent to the ellipse and the hyperbola in the first quadrant. Equation of the common tangents. So I would want to know the point of intersection of the hyperbola with the ellipse, right? In the first quadrant, the hyperbola and the ellipse, let's say, intersect at a point P, right? Whose x coordinate is x1 and y coordinate is y1, is the point where the ellipse touches the hyperbola in the first quadrant. Now, this will give me the x coordinate of the intersection of the ellipse with the hyperbola, and it will give me two equal values of x because of tangency. Because of tangency, this will give me two equal values of x. So the roots of this would be x1 squared comma and x1 squared would be the roots of this. Yes or no? The two roots of this will give me x square. One of the values of x square would be x1 squared. The other value of x square will also be x1 squared. Yes or no? Am I confusing you? No. And the sum of the roots, that is 2x1 squared, 2x1 squared would be minus b by a. So 36 x1 squared is 18, and in the first quadrant, therefore, x1 would be 3 root 2. x1 would be 3 root 2. Yes or no? So the point of tangency, the point where the hyperbola touches the ellipse, the point where the hyperbola touches the ellipse has x coordinate 3 root 2. Now to find the y coordinate, it's also this x equal to 3 root 2 is also a point on the hyperbola. So if you plug in x equal to 3 root 2 here, x equal to 3 root 2, then y becomes 3. Y becomes 3. If you plug in x equal to 3 root 2, y becomes 3. That means if x1 is 3 root 2, then y1 would be 3 because it's also a point on the hyperbola. That means I need to find the tangent at 3 root 2 comma 3 x1 y1, which is a point on the ellipse as well as the hyperbola where common tangents can be drawn. Yes or no? Now very simple. At x1 y1, the equation of the tangent to the ellipse, x1 by a squared plus y1 by b squared equal to 1. That's the equation of the tangent. That means equation of the tangent at x1 y1 y1 is going to be x by 36 into x1, which is 3 root 2, plus y1 y into 3 divided by 18 equal to 1. Yes or no? That will be the equation of the tangent, which you can simplify, of course. Got me right on this? All right. So we have a hyperbola whose center is the origin, and x plus y equal to 2 touches it at the point 1 comma 1. X plus y equal to 2 touches it at the point 1 comma 1, right? So here we have a hyperbola, and x plus y equal to 2 is a tangent. X plus y equal to 2 is a tangent at the point 1 comma 1. This is x plus y equal to 2. This is a tangent to the given hyperbola. And this tangent intersects the asymptotes at points A and B, right? Now if C is the center of the hyperbola, then the two asymptotes will pass through C. This would be one asymptote, this would be the other asymptote. Yes or no? A and B are points of intersection of the tangent with the two asymptotes. Yes or no? CA and CB are the two asymptotes, right? Now, it's given that AB is 6 root 2. The intercept made on the asymptotes. The intercept made on the asymptotes is 6 root 2. Now, one property that we learned was that P will always be the midpoint of AB. Didn't we learn that? P will always be the midpoint of AB. Have I told you this property? A tangent would intersect the asymptotes at A and B, and the point of tangency would be the midpoint of that segment, That's an important property, very commonly used, right? And therefore, PA will be equal to PB. Each will be 3 root 2. How about it? PA will be PB, each will be 3 root 2. Now, the parametric form of the equation of a line, this point is P, 1 comma 1, H comma K, and this tan theta for this line, the slope of this line is tan theta. So tan theta is -1, the slope of this line, isn't it? Tan theta is -1, and therefore sin theta is going to be 1 by root 2, and cos theta is going to be -1 by root 2. Yes or no? Cos theta is going to be -1 by root 2 for this line. Tan theta is -1, sin theta and cos theta would be these. Theta lies in the second quadrant very clearly, right? Therefore, to find the coordinates of A, h plus r cos theta, y plus r sin theta, k plus r sin theta. H is 1, so x coordinate is 1 plus r. R would be 3 root 2 for A. R would be 3 root 2 for A. Cos theta -1 by root 2. Y would be k, which is 1, plus r, which is 3 root 2, into sin theta, which is 1 by root 2. Yes or no? Right? Which turns out to be 1 minus 3 minus 2 and 4. So A has coordinates -2 comma 4. A has coordinates -2 comma 4. Yes or no? X is h plus r cos theta, y is k plus r sin theta, the parametric form of the equation of a line, right? So A has coordinates -2 comma 4 are the coordinates of A. The center is the origin. So far so good, yes or no? Can I just remove the clutter from here? I don't need it anymore. Now, P is the midpoint of AB. P is the midpoint of AB. That means the coordinates of B would be 2 plus 2, 4 would be the x coordinate, right? Because P is the midpoint. 2 minus 4 minus 2, that will be the y coordinate. Yes or no? I hope you understand what I did here. So far so good, right? So I know the coordinates of A and B. C, and these are the asymptotes. I know points A and B on the asymptotes, two asymptotes. So one of the asymptotes these are asymptotes passing through the origin. They are of the form y equal to mx. They are of the form y equal to mx. So one asymptote, for example, CA is one asymptote. That will be y equal to m. M is 4 minus 0 by minus 2. That means minus 2x. Minus 2 is the slope of this asymptote. Minus 2x. That means 2x plus y equal to 0 is one asymptote, isn't it? 4 minus 0 by minus 2. Minus 2 is the slope of this asymptote. The other asymptote, CB, is y equal to mx. This is also a line passing through the origin. Minus 2 minus 0 by 4 minus 0 minus half. Minus half is the slope of this. So minus half into x. That means 2y plus x equal to 0 is the other asymptote. Yes or no? 2y plus x is the other asymptote. So now I have knowledge of the pair of asymptotes. I have knowledge of the pair of asymptotes. 2x plus y equal to 0 and 2y plus x equal to 0. The combined equation of the asymptotes is going to be 2x plus y into 2y plus x equal to 0 would be the combined equation of the two asymptotes. Clear? Yes or no? Which is like 2x squared plus 2y squared plus 4xy plus xy 5xy equal to 0 is the combined equation of the pair of asymptotes of the required hyperbola. Yes or no? Right? Now if this is the equation of the two asymptotes, then the equation of the hyperbola will differ only by a constant. The equation of the hyperbola would be this plus c equal to 0. That will be the equation of the hyperbola. Yes or no? So the hyperbola will be 2x squared plus 2y squared plus 5xy plus c equal to 0. C is a constant. The equation of the hyperbola differs from the equation of the pair of asymptotes only by a constant plus c. Now, how do I find this c? Right, absolutely. 1 comma 1 is a point on this hyperbola. So 1 comma 1 satisfies this equation. So p lies on this hyperbola. So 2 plus 2, 4 plus 5, 9. So c turns out to be minus 9. C turns out to be minus 9. So the hyperbola turns out to be 2x squared plus 2y squared plus 5xy minus 9 equal to 0 is the equation of the hyperbola. Right? So the asymptotes are 2x plus y equal to 0 and 2y plus x equal to 0 are the two asymptotes. Their combined equation is this, which is 2x squared plus 2y squared plus 5xy equal to 0 are the two asymptotes. So far so good. Yes or no? Now, once I know the asymptotes, how do I find the equation of the axis? Angle bisectors between the two asymptotes will be the transverse and the conjugate axis. Yes or no? The angle bisectors between the two asymptotes, that's always the transverse and conjugate axis. Right, isn't it? The angle bisectors between the two asymptotes would be the transverse and conjugate axis. So all that I need to do is find the angle bisectors between the lines 2x plus y equal to 0 and 2y plus x equal to 0. So to find the axis, that is transverse axis and conjugate axis, 2x plus y divided by root 5 equals 2y plus x divided by root 2 square plus 1. This would give me the two angle bisectors. One of the angle bisectors would be the transverse axis, the other one would be the conjugate axis. Yes or no? Right? And they will be perpendicular, that because transverse and conjugate are perpendicular. All right. So this gives me like 2x plus y equal to plus minus 2y plus x. Plus will give me one of the axis, minus will give me the other axis. Yes or no? So this gives me like 3x plus y. That means one is x plus y equal to 0. The other one is plus, so x minus y equal to 0. These are the two axes of the hyperbola. These are the two axes of the hyperbola. Yes or no? But the contention is, see, in a very general sense, suppose they give you the generalized equation of a hyperbola, right? Say ax squared plus 2hxy plus by squared plus 2gx plus 2fy plus c equal to 0. All right. And they give you two lines that are meant to be the transverse and conjugate axis. But you do not know which one is the transverse axis and which one is the conjugate axis. How does one figure out, given the equation of the hyperbola, how does one, in a very general sense, figure out that this one must be the transverse axis of the hyperbola and that one must be the conjugate axis? Yes. Between the two lines, between the two axes, one will intersect the hyperbola at real points, and that one must be the transverse axis. Now, in this case, between these two, I can see by inspection 1 comma 1 is a point on this, and 1 comma 1 is also a point on this. So this line will intersect the hyperbola at 1 comma 1. That means this is the line intersecting the hyperbola at real points, and this must be intersecting the hyperbola at imaginary points. Therefore, this must be the transverse axis and that one must be the conjugate axis. Just check that. X plus y equal to 0, for example. If you plug in x plus y equal to 0, that means to find the intersection of the hyperbola with x plus y equal to 0, you get 2x squared plus 2x squared minus 5x squared minus 9 equal to 0. plugging in y equal to minus x to find the intersection of x plus y equal to 0 with this hyperbola, right? And this gives me minus x squared equal to 9. Will this give me real values of x? That means this line is not intersecting the hyperbola at real points. This therefore must represent the conjugate hyperbola. I'm sorry, the conjugate axis, and this must be the transverse axis. Yes or no? So far so good. Hey, this was the asymptotes, this was the hyperbola. What would be the equation of the conjugate hyperbola? Yeah, this will become plus 9. Everything else will remain the same. This will become plus 9. Average between plus 9 and minus 9 will be the 0 that comes after 5xy. Yes or no? Okay. Now, good for us. Can I wipe this off? So I know the transverse and the conjugate axis of the hyperbola. Can I just remove the figure and create room for a fresh figure? So the transverse and the conjugate axis are these. This is not the x-axis, this is the line x minus y equal to 0, which is the transverse axis of the hyperbola. This is x plus y equal to 0, which is the conjugate axis of the hyperbola. The point where they intersect is the origin, is also the center of the hyperbola. Yes or no? And the line x minus y equal to 0 will intersect this, as we have seen by inspection, at 1 comma 1. At 1 comma 1, isn't it? 1 comma 1 is a point on this, is also a point on this, but otherwise if it is not given, how would you find the vertex of the hyperbola? The vertex of the hyperbola is the intersection of the hyperbola with the transverse axis. Now I could see by inspection in this case that 1 comma 1 lies on this, 1 comma 1 also lies on this from our earlier calculations, and therefore 1 comma 1 must be a common point between the transverse axis and the hyperbola. 1 comma 1 therefore must be the vertex. 1 comma 1 must be the vertex of the hyperbola. Right? All's good so far, right? Huh? Now, the small a that we talk of in a hyperbola, semi-transverse axis, is what? The distance between the center and the vertex. Center, this length is small a, right? And again, as you can see, this small a is CA, which is root 2. Yes or no? This is root 2. Right? And if I take any one of the asymptotes, say this is one of the asymptotes, say call it 2x plus y equal to 0 is one of the asymptotes. Okay? This is the transverse axis. This is one of the asymptotes. And suppose this angle is theta, then the eccentricity of the hyperbola would be sec theta. Eccentricity of the hyperbola is going to be sec theta. Yes or no? Angle between one of the asymptotes and the transverse axis, if that's theta, then sec theta will give me the eccentricity of the hyperbola, right? So if I can find now, the slope of this line is known. What's the slope of this line? Minus 2. What's the slope of this? 1. The transverse axis has slope 1. So can I find tan of the angle between two lines? Tan of the angle between two lines is acute angle is going to be given by mod of m1 minus m2 by 1 plus m1 m2. So m1 minus m2, m of this, which is minus 2, minus m of this, which is 1, divided by 1 plus minus 2 into 1. Yes or no? Which is 3. Tan theta is 3. So sec square theta would be 1 plus tan square theta. Sec square theta is 1 plus tan square theta, means 10. So the eccentricity, which is sec theta, is root 10. Eccentricity known, A known, E known. Yes or no? See, we've unleashed everything about the hyperbola, almost everything, right? Now, can I just remove this portion? Now, the directrix, this is the conjugate axis. The directrix is always parallel to the conjugate axis. Yes or no? The directrix is always parallel to the conjugate axis, right? So take cognizance of all these physical attributes of the hyperbola rather than its ornamental equation. All right. So if this is the conjugate axis, the directrix, see, conjugate axis is x plus y equal to 0 is the conjugate axis. Conjugate axis is x plus y equal to 0. So the directrices must be of the form x plus y equal to c, and the distance between the directrix and the conjugate axis is a by e. The distance between the directrix and the conjugate axis is always a by e. Now that means the distance between these two lines is what? Mod c by root 2 is the distance between these two lines, the directrix and the conjugate axis, and that must be a by e. What is a? A is root 2, e is root 10. So a by e is 1 by root 5. A by e is 1 by root 5. Yes or no? Therefore c must be plus minus root 2 by 5. One value will give me one directrix, the other value of c will give me the other directrix. Yes or no? Right? Now that means one directrix is x plus y plus c root 2 by 5 equal to 0. The other directrix is x plus y minus root 2 by 5 equal to 0 would be the other directrix. The combined equation would be this into this equal to 0. So the combined equation of the two directrices d1 and d2 is going to be their product equal to 0. Their product is x plus y whole squared minus 2 by 5 equal to 0 would be the combined equation of the two directrices. Right? Yes or no? Which would give me 5x squared plus 5y squared plus 10xy minus 2 equal to 0 would be the combined equation of the two directrices. So far so good, right? Learn this. Learn to deal with the generalized equation, keeping track of the physical attributes of the entity. That's very important, right? Don't just get lost in a standard equation of a hyperbola. The standard equation is meant to communicate some physical attributes which will apply equally to the generalized format. That's important to understand, right? Now, so far so good. So I have the combined equation of the two directrices. So option 4, problem number 4, we know. Okay, now equation of the tangent at minus 1 comma 2. Now that's very simple. Tangent at any point is the hyperbola. X squared to be replaced by x into minus 1. The y square to be replaced by y into 7 by 2. And xy to be replaced by half of xy1 plus x1y minus 9 equal to 0. That will give you the equation of the tangent. X squared to be replaced by xx1. Y squared to be replaced by yy1. Xy to be replaced by half of xy1 plus x1y where x1, y1 is minus 1 comma 7 by 2. You can find the equation of the tangent at minus 1 comma 7 by 2, whatever it turns out to be now. I want to be able to see, this is not the x-axis. This is x minus y equal to 0, which is my transverse axis. This is x plus y equal to 0, which is my conjugate axis. Right? And this equation of the hyperbola, is not with respect to this being the x-axis and this being the y-axis. I now choose to find the equation of this very hyperbola, imagining that this is my x-axis, the transverse axis is my x-axis, and the conjugate axis is my y-axis. I want to be able to find the equation of the hyperbola commensurate. Yes or no? Right? Now, look, E is known, A is known. A for the hyperbola is known, which is the semi-transverse axis, which is root 2. E we computed 10. The semi-conjugate axis B squared is A squared into E squared minus 1. The semi-conjugate axis, yes or no? Which is A squared, which is 2 into 9. So B then turns out to be 3 root 2. B then turns out to be 3 root 2. Okay. All's good. Can I just remove the nonsense from here? Right? No, it's not nonsense. Let me now. So this line, which was the transverse axis, is now my x-axis. This one, which was the conjugate axis, is now my y-axis. And refer to this and this as the axis. The equation of the hyperbola is going to be x square by a square. A square is 2 minus y squared by b squared, which is 18, equal to 1 would be the equation of the hyperbola. Refer to this as the x and the y-axis. Yes or no? Let's look at the third comprehension. Hello? Comprehension 3. Which is about a hyperbola x squared by a squared minus y squared by b squared equal to 1. Hello? Can there be some silence? So which is hyperbola in a standard form. Center of this hyperbola is 0, 0. The transverse axis is the x-axis, the conjugate axis is the y-axis, the origin is the center of the hyperbola. This is one of the branches of the hyperbola, right? Now, I choose a point P on this hyperbola with eccentric angle theta. That means this point must be A sec theta, B tan theta, right? Now what they do is, they draw a normal at this point P of the hyperbola. A normal is drawn at this point P of the hyperbola. This is the normal. And what's the equation of the normal at theta? Normal at theta is given by ax cos theta plus by cot theta equal to a square plus b squared. Yes or no? Right? Now this normal intersects the transverse and conjugate axes at capital G and small g respectively. That means this point is capital G and this point is small g. F is the foot of the perpendicular to the normal at P from the center C. This is the center C, which is the origin. and F is the foot of the perpendicular from C onto the normal at P. We want to be able to find the value of PG squared. Now that's very simple. Can I not find the coordinates of G? In this, put y equal to 0. So the coordinates of G will turn out to be a square plus b squared by a sec theta. Yes or no? This would be G. A square plus b squared by a sec theta comma 0. Such would be the coordinates of capital G, right? Now, to find PG, all that you need to do is use distance formula. PG squared is a sec theta minus a square plus b squared by a sec theta whole square plus b squared tan square theta. Yes or no? Right? Which is like b to power 4 by a squared sec square theta plus b squared tan square theta, which is b squared by a squared b squared sec square theta plus a squared tan square theta. That's PG squared. Yes or no? This was fairly simple, isn't it? Ordinary distance formula. Clear? That's part 1 of the problem. Now, that is 7. Number 8. We want to find PF squared. We want to be able to find PF squared. There's a lot of noise. PF squared. Now, any suggestions for finding PF squared? Any bright ideas on finding PF squared? We know the value of? We don't know FG. Any smart ways of doing this? You don't want to take the trouble of finding the coordinates of F, right? Foot of the perpendicular from 0, 0 to this line. Now that's ugly, isn't it? That's ugly. You don't want to do that. Look, let's do the following. At P, draw a tangent. At P, draw a tangent. And do you know the equation of the tangent? The equation of the tangent is x by a sec theta minus y by b tan theta equal to 1. That's the equation of the tangent at theta. Now, would you mind believing that FP is the same as CQ? Is FP not the same as CQ? This is a rectangle, isn't it? And all that you need to find is the distance of C from this line. Distance of 0, 0 from this line, that will be CQ. That will be the same as PF. Yes or no? Right? PF is the same as CQ. And CQ is distance of 0, 0 from the tangent at P, isn't it? Which would be 1 by root sec square theta by a squared plus tan square theta by b squared. That's the distance of 0, 0 from the line. Yes or no? That will be CQ. That will be the same as PF. Is it not? Clear? Now, so PF squared, you know, so simple to find. Clear? That's problem 8. Let's move to problem 9. Really? So if the previous two were not given, say the previous problem was not given. In the next problem, we need to find PF into PG is what we need to find. In the next problem, we want to find PF into PG. Huh? Huh? What all? Okay. Let's take a few steps back. Go back to circles. 1. If this was the equation of a circle S equal to 0. Alright. And if P was an external point, say P x1, y1. Then PA into PB was the power of the circle with respect to P. PA into PB was S1. The value of S at x equal to x1 and y equal to y1. Now, if P was a point outside the circle, then S1 would be positive. But if P was a point inside the circle, then PA into PB will still be S1 but will turn out to be a negative number. In this case, PA into PB, if P was a point inside the circle, will turn out to be a negative number, will still be S1. It's as if PA is positive and PB is negative. A and B as if they are lying on the opposite sides of P. So in this case also, PA into PB, magnitude of that will be magnitude of S1, because if P was a point inside, then S1 would be negative. PA into PB will turn out to be a negative number. Take the modulus of that. That will give you mod PA into mod. PB would be mod S1. Power of a circle with respect to the point P holds good irrespective of whether the point is inside the circle or outside the circle or on the circle. Right? PA into PB will still be S1, just that it will turn out to be a negative number. Take the mod of that. That will give you mod PA into mod PB. No? Now, hop in. Suppose what I do is, think of it. I draw a circle with CG as the center. It will pass through F, isn't it? Because then this is 90 degrees angle in a semicircle. Circle with CG the center, then P would be a point inside the circle. Yes or no? So, circle with CG the center. I'm sorry, with CG the diameter. With diameter CG is x minus 0 into x minus a square plus b squared by a sec theta plus y minus 0 into y minus 0, y squared equal to 0. This is the circle with diameter CG. This is the circle with diameter CG, yes or no? And P, this is x1, y1. Therefore, PF into PG would be, this is my S. The value of this at x equal to this and y equal to this will give me PF into PG algebraically. You know what I'm saying? PF into PG, and it will turn out to be a negative number because P would then be a point inside the circle with CG the diameter. Yes or no? So PF into PG is S1. The value of S at x equal to this and y equal to this. Let's see what it turns out to be. Let's find out the value of this. So put x equal to a sec theta. So a sec theta into a sec theta minus a square plus b squared by a sec theta plus y squared. Y squared is b squared tan square theta. that will be the algebraic value of PF into PG, and it should turn out to be a negative number. If I take the mod of that, that will give me mod PF into mod PG. Yes or no? Let us see what it reduces to. This is a sec theta will get cancelled. So this is like a sec theta into b squared by a with a minus sign sec theta, so sec square theta plus b squared tan square theta. That's PF into PG algebraically. I take minus b squared common from this, sec square theta minus tan square theta, which is a negative number, minus b squared as I expected, because p is a point inside that circle. Power of the circle with respect to p inside. Therefore, mod PF into mod PG must be mod of this, which must be b squared, must be b squared. Are you okay with this? Remember, whether P is inside a circle or outside the circle, the algebraic value of, say, PA into PB will always be S1. If P is inside, S1 will turn out to be negative. If P is outside, S1 will turn out to be positive, and that's referred to as the power of a circle with respect to a certain point, P. Got me? Option C. Right? All's good, isn't it? Comprehension 4. There is a circle given to you, x square plus y squared minus 8x equal to 0. And there is a hyperbola given, x square by 9 minus y squared by 4 equal to 1. And these two curves are known to intersect at points A and B. First of all, we want to be able to find the equation of common tangent with positive slope, which is a tangent to the circle as well as to the hyperbola, right? So any tangent to this hyperbola must be of the form what? Y equal to mx plus root a squared m squared 9m squared minus 4. Yes or no? And if it's also a tangent to the circle, this circle has center 4, 0 and has radius 4. That means distance of this line from the center of the circle must be equal to 4 for this line to be a tangent to this circle. Now, what's the distance of this line from 4, 0? 4m plus root 9m squared minus 4 mod of this divided by root 1 plus m squared, distance of this line from the center 4, 0, and that must be equal to the radius 4. Such must be m. Yes or no? Have you solved for m? Cross multiply, simplify, square, etc. You can solve for m. Okay. Clear? What you could do is, you know, in a ugly situation of this kind, take recourse to the options. Slope m, you mean to say if slope is m, m is 3 by 4, m is 3 by 4 will satisfy this equation. M is 3 by 4, plug m equal to 3 by 4, does it satisfy this equation? Huh? M is 3 by 4, so this will become 3. This 9 into, it will become an irrational number. No, it will not. M is 3 by 4 will not satisfy this equation. M is 3 by 4 will not satisfy this equation. M is 4 by 3 will also not satisfy this equation. The other two, see, 3 by 4 is not satisfying, 4 by 3 will also cause it to be irrational, will not satisfy this equation. That means the other two lines have slope 2 by root 5. Check if m equal to 2 by root 5 satisfies this equation. This is likely to be the slope. I'm not sure, but I mean, there could have been, in this case, there is none of these. And C and D, of course, I can see it's not satisfying. So the other two lines have slope 2 by root 5. So m equal to 2 by root 5 must satisfy this equation. Can you see that? Does it? Have you checked the values? Have you checked? Put m equal to 2 by root 5. M equal to 2 by root 5 is satisfying this? Okay. So in a situation where the equation gets so ugly, check with the options. There are 3 values of m that you need to check with: 3 by 4, 4 by 3, and 2 by root 5. Right? That's easier to do than to solve this equation. Right? So m equal to 2 by root 5 is satisfying this? Right? Very good. So m equal to 2 by root 5. So I... Huh? Okay, that also. 2 by 5. 2 by 3. 2 by 3 less than 2 by root 5. Not true? Yeah, it is. It is. Yes, it is. All right. Equation of the circle with AB the diameter. In this case, you know, you can solve these two equations. Plug in y squared in this. Y squared in this equation you can plug in as 8x minus x squared. 8x minus x squared. So x squared by 9 minus 1 by 4. Y squared is 8x minus x squared equal to 1. And you can solve for x. That will give you x of A and x of B. Right? And once you know x, you know y. So you know the coordinates of A and B, and you can find the equation of the common chord AB. Right? Okay, so this is fairly all right. Number 12. Rudro. Gautam ke bol bhi ek bar ekhane. Right. All right, number 12 then. Problem number 12. A circle cuts two perpendicular lines so that each intercept has a given length. This is a circle. Along the x-axis, it cuts an intercept 2L1. Along the y-axis, it cuts an intercept 2L2. There are many circles of this kind, right? We want to be able to find the locus of the center of all such circles. We want, and then, in fact, they say it's a conic. We want to be able to find the eccentricity of the conic described by the center of such circles. Right? First of all, let's examine the nature of the conic that the center would describe. Suppose the center C has x coordinate h and y coordinate k. Right? Now, this length is h, this length is L1, this is radius r. So can I say r squared is h squared plus L1 squared? Can I say this? R is the radius of this circle. Okay. Now, look at this. This is R. This is K. Okay, call this L2. This is L2. This is L1. Okay, L2. So sorry. L2 squared. All right. All right. Now, this length is L1. So R squared would be K squared plus L1 squared. Where L1 and L2 are fixed numbers. Yes or no? So H squared minus K squared, the center of the circle, X and Y coordinates of the center, is like L1 squared minus L2 squared. Generalize. X squared minus Y squared is L1 squared minus L2 squared. That's the locus of the center. The X and Y coordinates of the center satisfy this equation, which is a rectangular hyperbola, So the locus of the center is a rectangular hyperbola with eccentricity, of course, is root 2. A rectangular hyperbola is eccentricity root 2 for sure. Yes or no? Got me? So option C. I hope all of you understand this. Huh? 13. Match the columns. We have a hyperbola and an ellipse. Hyperbola is x squared by a squared minus y squared by b squared equal to 1 is the hyperbola. The ellipse is x squared by a squared plus y squared by b squared equal to 1. Let me assume that small a is the semi-major axis, small b is the semi-minor axis. The eccentricity of the ellipse is E1, the eccentricity of the hyperbola is E2. Now, the foci of the hyperbola will be given by AE2, x equal to AE2, and that becomes the vertices of the ellipse. That means small a must be AE2. The vertex of the ellipse is the focus of the hyperbola, right? Also, the focus of the ellipse be the vertices of the hyperbola. Focus of the ellipse is going to be AE1, and that turns out to be the vertex of the hyperbola. Yes or no? Right? Very clearly, one thing, if you multiply these two, then AA is AA E1 E2, product of the eccentricities. So E1 E2 turns out to be 1. E1 E2 for sure turns out to be 1. The product of the eccentricities of the hyperbola and the ellipse is 1, right? Okay. Now, what is B by B? What is B squared? B squared would be A squared into 1 minus E1 squared. That's B squared, right? Which is A squared minus A squared E1 squared. But A squared E1 squared is capital A squared. So this is A squared minus capital A squared. That's B squared, right? Capital B squared is capital A squared into E2 squared minus 1, which is A squared E2 squared minus A squared. But A squared E2 squared is A squared, small a squared. So this is A squared minus capital A squared. Very clearly, B squared is the same as capital B squared. So small b must be equal to capital B. Small b by capital B therefore must be 1, right? E1 plus E2. See, E1 plus E2, where E2 is the eccentricity of the hyperbola, will never be equal to 1, will be greater than 1 always, right? Is E1 plus 1 by E1, because E1, E2 is 1, will always be greater than 1, isn't it? A plus 1 by A, if a is greater than 0 will always be greater than or equal to 2, sorry. Greater than or equal to 2, it can't be equal to 2. Why? Because E1 and E2 can't be equal to 1. Right? So E1 plus 1 by E1 is always greater than 2. A plus 1 by A is always AM greater than GM. Right? So this will always be greater than 2. So it cannot be 1, it cannot be 2. So it can be 3 or 4. It can be 3 or 4. Right? Now, the angle between the asymptotes of the hyperbola is 2 pi by 3. That means 2 theta is 2 pi by 3. Theta is pi by 3. And eccentricity is given by sec theta, isn't it? Eccentricity is given by sec theta, sec of pi by 3, which is 2. Eccentricity of the hyperbola is 2. Clear? You're right, in which case it will become 2 by root 3. 2 by root 3. So we will assume that this is the angle corresponding to that hyperbola, x square by a squared. We will assume that in absence of any further data. You're right, that's a possibility. Now, if E1 is 1 by root 2, if E1 is 1 by root 2, E2 will be root 2, isn't it? Which would be a rectangular hyperbola, right? Under such circumstances, if xy be the point of intersection of the hyperbola with the ellipse, we want to be able to find the value of x square by y square, right? Now, if E2 is root 2, very clearly this is a rectangular hyperbola. So capital A will be equal to capital B, isn't it? In a rectangular hyperbola, capital A is capital B. And therefore, if you plug into this, capital A equal to capital B, what do you get? 1, for sure, we have found small b is the same as capital B, right? And capital A turns out to be capital B. Capital A turns out to be equal to capital B. So this is a squared minus b squared. But this is the same as small b. So this is a squared minus b squared. B squared is a squared minus a squared, and capital A is capital B, which is a squared minus b squared. So 2b squared is a squared. So 1, capital A is capital B, and capital B is the same as small b, and b squared is the same as a square by 2. B squared is the same as a square by 2. Yes or no? Isn't it? Now what we want to find is x square by y square, where x and y, xy is the point of intersection of the ellipse with the hyperbola. All right. Can I just wipe this off? So if xy satisfies this and satisfies this, let me subtract these two. If I subtract these two, then I get x squared into 1 by a squared minus 1 by a squared plus y squared into 1 by b squared plus 1 by b squared is 0, is what I get. Right? Then divide by y squared. This will become 2 by b squared because capital B has turned out to be the same as small b. So x square by y square into a squared minus small a squared by a squared is minus 2 by b squared, isn't it? This is 2 by b squared minus 2 by b squared, right? And all that you need to do is use this to find the value of x square by y square. All right?